Sixth grade, happy Thursday. Yesterday you were working on a project, taking on one of the biomes and trying to develop a PowerPoint slide. Hope that went well for you and that you learned a little something interesting with it. Today we're just going to finish up the chapter with the math and science part. You have the worksheet sitting out for you. I was just going to show you the experiment that they had at the end of the chapter. It was taking a lamp and you put a thermometer on a ruler and you stick it in here. So they have it sit for 3 minutes, guys, at a 90-degree angle. So the heat from the light's going to bash right into that. And then you're going to do it again, this time angled back, and then this time angled even further. And what they're trying to teach you is, guys, the more of an angle, the hotter it's going to be, thus showing you why it's always warmer at the equator than it is the farther north you go. So the farther north you go away from the equator, the more that the earth gets tipped like this, and the heat, instead of going directly into the thermometer, gets reflected off and reflects off. In your book, guys, they had showing you that. It says the distance from the equator, which is 0 degrees latitude, is often a good predictor of temperature. The farther from the equator, the colder the climate. So they just show you this, guys, with 3 cities they picked. So equator would obviously be 0 degrees latitude. Now they also ended it with the same is not true with distance of prime meridian, guys. Left or right doesn't matter. It's up and down from the equator. So the equator would be the hottest. You can see as they move 30 degrees north, the average temperature was 21 degrees Celsius. Remember, to switch that over, you multiply by 9/5. So if I would divide this number by 5, it would be 4 times 9 would be 36, and then add on 32 to that. So that would give you an average temperature of like nearly 70 degrees. So this is Egypt, which is 30 degrees north of the equator. It averages 70 degrees for the year. Same thing as you head south of the equator. A little bit cooler, guys, but still, if I would take this as 15 divided by 5 is 3 times 9, 27, add 32, it would be like 60 degree average. 60 degrees north, so we moved farther north from the equator, we got an average of 5. So this is like 40 degree average temperature in Helsinki, Finland. So the farther north it is, the average, the colder it's going to be, because of the tilt of the earth and the sun's rays not hitting it directly. Okay. All right, let's try your worksheet now. It goes like this. We're using a chart to calculate the mean, median, and mode. Math class at its best. The chart shows the average yearly rainfall for a region in England from 90 to 2003. So use the chart to answer the questions. What was the mean average rainfall from 1990 to 1996? So we're over here on the left side, guys, and we need to do the average. So step 1, I need to add those all together. And so I'm going to get my little fancy scratch piece of paper here on my math thing, and I'm just going to start writing those things all out and check to see how I did when I add them all up. So I have 820 plus 740 plus 710 plus 800 plus 1000 plus 990 and plus 890. And I added those all together, and I got 5,950. And I hope some of you are doing the work with me and checking it over to see if I'm right. Now, guys, be careful. Some of us would be tempted to say, now divide by 6. It's not 6, guys. It's actually 7. 2, 4, 6, 7. Okay? So I'm going to take my answer. I'm going to divide it by 7, and it goes in there 850. So it makes me feel good. At least it came out evenly. That helps me think that I might have done it right. So it's 850 millimeters, guys. So don't get excited like, wow, that's a lot of rain. They're measuring in millimeters. So if you switch it to centimeters, you'd chop off that 0. Divide by 2.5 would switch it to the amount of inches this place is getting. Number 2 didn't print very good. It says this. What was the mean average rainfall on the other side? So we're going to do the same exact thing. Here we go. I'm writing down 780 plus 810 plus 940 plus 820 plus 1120 plus 810 plus 1180. When I add those together, I got 6,460. I divide that one by 7, and it does not come out evenly at all. It came out to 922. I'm going to round up to 923. Okay, and my label is millimeters. Question 3. How do these two periods of time compare? Write a number sentence and then explain in words. So my number sentence goes like this. 850 is less than 923. So that's my number sentence, guys. I just wrote the numbers math symbols. I wrote 850, and I gave the less than symbol is less than 923. Now I'm going to explain that in words, and I'm just going to write, we got less rain from 1990 to 96 than we did from 1997 to 2003. Okay, so they teaching you this math, and then off we went. Okay, so repeating that again for you, math symbol was 850 is less than 923, and I just wrote we got less rain in 1990 to 1996 than we did in 1997 to 2003. Number 4, do the data on the chart support this hypothesis? There has been a trend toward a steady decrease in rainfall in this region. The answer is no. How can I explain my answer? We're averaging more rain in the last 7 years than we did in the first 7 years. So we're not decreasing, guys. If you look at this stuff, this was, started here, down, down, up, down a tad, down, up, down, up. So no, there's no trend of a steady decrease. And when we did the average, guys, we got more here than we did there. So I just wrote, nope. The last 7 years had more rain than the previous 7 years before that. Okay, practicing a little math skills, looking at the way climate works and operates. Happy Thursday, guys. We'll get ready for the test tomorrow, working with these biomes. Best of luck to you on that. Have a great day.